Let's practice this a little bit more here. So we're basically doing what we just did. We want to write a similarity statement comparing these three triangles. Okay, so I'm going to do this a little bit differently this time, and maybe I'm going to outline all the triangles that we're looking at. So again, we have this altitude right here that goes from a vertex to the opposite side of the triangle, and it takes the perpendicular path here. Okay, so we know that because this segment right here, that UV, again, maybe I'll just draw this in green for a second here. Because we know that UV is a straight angle, okay, we know that since this is 90 degrees, that the other angle has to be supplementary, or it's supplement, so we know that this is actually going to be 90 degrees as well. So we're going to go ahead and make this 90 degrees as well, okay, and I'm going to just erase maybe this green side here, okay. So perfect. So I'm going to maybe talk about this whole triangle, this big one, as like the red triangle. Okay, and maybe we're going to have a green triangle here as well. So maybe let's make the medium-sized triangle a green triangle. Okay, and then I'm also going to make the smallest triangle the blue triangle. Okay. And so we can maybe see this problem just a little bit better. Okay, now all I'm going to do here, if we're trying to identify these three triangles, or kind of like which statement we can actually make here, I'm just going to draw these right triangles here with the short side, hypotenuse, and the longer leg here. And I'll say that's my right angle. Okay, we said the medium-sized one was green, so I'm going to make this again shorter. Okay, a little bit smaller. Okay, and then finally this last one we'll call just again basically the blue triangle, or the smaller one. Okay, now let's just go through and maybe identify the vertices. So the bigger right triangle, or the red one, we can see is that the right triangle here is like the vertex W. Okay, so I'm just going to write W here. Okay, we can see that for the green triangle, that the right angle here is actually going to be Z, and so I'm just going to write Z right here. And finally, for the blue triangle, it looks like the right angle there is also Z. Okay, now let's look at the shortest distance, at basically which leg is shorter for the big triangle. Okay, I can see that from W to V is a shorter distance than W to U, and so I'm going to call this shorter distance WV, and then that must mean that that last vertex here of the triangle is U. Okay, when I look at the green triangle, remember our 90-degree angle here is Z. It looks like it's a shorter distance to W than it is to U. So I'm going to go ahead and call this Z to W. That's my shorter one. And then U must be my longer leg here. So that's going to be my last vertex. And then finally, the smallest triangle, the blue triangle, okay, since Z is my 90-degree angle, my shorter leg looks like it's going to be ZV. So I'll put V here as my shorter leg. And my longer leg must be ZW, so I'll put W right here. Okay, and now all we want to do is just make this statement that all these triangles are similar, remembering that ordering actually matters. Okay, so it's actually true if this is a right angle, we have to say that all these angles have the same measure, and that angle U, and angle W here also actually have the same measure. And so all I'm going to do is say maybe this is triangle UVW is similar to triangle UWZ, which is similar to triangle WVZ. Okay, and this would just be my similarity statement. Okay. Again, I hope the different colors kind of help out there. I definitely think it does. But all our goal here is to just kind of identify how these triangles are similar and how we can actually make that particular statement.